Okay, we're on air live. Here we go, lesson 14 quiz.
Perfect. Okay. Everyone got it open?
Yep.
Okay.
Okay, in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different than the others.
It's true, right? Yeah.
Yep.
True. Yep. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
So sample means all positive, and data in each group are normally distributed.
Yep.
But not the third one, right?
Yep.
Not the third one.
Okay.
Yep.
Okay. Question
Right.
5. To check if the group is normally distributed, do the following. That would be a QQ plot, isn't it?
Yeah.
They also, oh, it doesn't say check all that apply. Histogram.
Yeah, histogram might tell you. Normal is scattered plot. Okay. Point 6. We assume the variation in each group is the same if the following happens. Largest variance is 4 times. Oh, no, it's not that one, is it?
Yeah, the largest variance is less than 4 times the smallest variance.
Okay, I read that wrong. I left out the less.
Yeah, the variance.
Okay. Question 7. Conducting 2 independent sample tests between 2 pairs. If there are 3 samples, there are 3 pairs. How many pairs will there be if there's 4 samples? 6.
All right.
Everyone agree with that? 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4.
Yep, that's right.
6.
Okay.
Yeah. Now we got to paste all that shoe data into the quantitative document.
Okay, so soccer shoes. Okay, let's get that. Shoes got to separate.
Okay. Including the socks. So don't forget the socks. Okay, I have an answer of 5.216. No, hold on. That's what is this? Mass variation. That's not right. Is the smallest
What is the minimum cost variance?
variant the smallest standard deviation?
The smallest variance is 27.208, which is variable 3.
Yeah, but when it says what is the minimum, the smallest variance for all 6 groups, is it talking about? So is it talking about what the number is?
What is the minimum, the smallest variance for the 6 groups? So out of all the 6 groups,
okay,
they're listed, it would be variable number 3, 27.208.
misunderstood that. I thought we were looking for the difference between the smallest one between the variances.
The variance is the standard deviation. So 27.208.
And then the
answer.
maximum is 53,158.
What's number 9?
53.158. I didn't read the quiz.
Okay, so 10. The test for equal variances is satisfied for these data. So yep.
How do you know that?
Because 53.158 is greater.
No, he's not
I
4
think
times.
this is where in that video it makes me wonder about that previous one where it says 4 times.
Yeah.
In the book, something about 4 times, but it was showing in the video that you take the 27.208 and times it by itself,
4.
or maybe that was by. What was the one that was by 2? Was that the mean? No, it wasn't the mean. There's some that you times it by 2, and as long as it's not twice as big. 53.18 isn't even twice as big as the 27.208, so we're safe.
If the smallest variance squared is, or if the largest variance squared is, never mind.
I guess that would be.
I'm in the middle of copying and pasting right now. My Excel's not. This clipboard's not working. I don't know what's going on.
Is it your variance part that isn't working?
I still can't get the data into Excel. My clipboard's not working. Now it's starting to work now. Copy, paste.
So I've got true for number 10.
True for 10.
Oh boy. Got to do a QQ plot for each of the 6 samples, which is the same thing approximately based on what you see. So if we each do 2.
Yeah, I've done all of them. The only one that worries me really, 2.
The second one?
Yeah, the second one worries me. But
Okay, let me look at that.
but what's weird is if it's false, we can't do this because don't you have to have them normal for all of them?
Yep. Let me see. So there's just a couple outliers on that. I mean, there were some in some of the
Say 2 or 3.
2.
2's the worst, and then no, 2's the worst, and then 3 and 6 are not as bad, but 2's definitely the worst. You can assume it's true.
Just those middle things. I'd still say that they're fairly, nothing going way out there.
Okay.
Compared to some of the stuff that I saw in the preparation thing and the homework.
Yeah, I'll be ready in like A few more minutes.
Assume it's normal. Yeah, they're approximately normal.
Yeah.
That's a true or false, we'll find out. This one says
Okay.
perform a test in SPSS. So if we don't have SPSS, we have a
Yeah, Excel. So all we have to do is remove the SOC value.
move the SOX data and perform the test again. What is the p-value when we remove the SOX data? So the very last one, variable
0.
6, we delete.
0.309.
Yep. 0.309.
Yep.
So, yep. 309. The test statistic for an ANOVA hypothesis test, an F statistic, is the p-value, the area to the right. Statistic
To the right.
to the right.
Well, I thought that. But now when I see the F value is much bigger than the P value, I'm wondering if it's closer to the Y value, or am I just overcomplicating things?
No, your F is going to be a thing, and then it's always at the right tail, to the right of that, the
Okay.
rightmost part of the tail.
Yeah. Okay. Oh, now we got to load the dash data. Let me do that quickly.
All right, let me clear my other one. So,
Sodium levels, eh? So the second column C.
got beef, meat, poultry, and then we've got calories and sodium in each of those. What are we doing?
Yeah. Sodium.
Calories.
Yeah, that's right. That's why your cousin is good. These two are picked on too much.
Well, this says, let's examine the calories first.
Oh, I thought it said the sodium.
No, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs.
Oh, man. Yeah.
See, I'm telling you, that's where it comes in handy that we work as a group. That's where I mess up on my test. I look at something really quick and jump with it.
My machine's hanging now.
Poultry.
Oh my gosh, it looks like this. That's good.
Okay, so what are we looking for? Let's examine the construct QQ plots of the calories.
You want the QQ plots, and we just paste it all there.
We each gonna do one. I'll take variable 1. Look at that QQ plot.
Variable 3.
Okay, Brandon, you got variable 2?
Yeah,
All right.
which was
Potatoes.
meat. Is that variable too?
Yep.
Copy. All right.
Yeah.
Where do we go to type in the QQ plots? I can't remember.
The
You have to go-
quantitative statistics spreadsheet.
Oh, the other thing. That's right. Okay.
Yeah, the very first one that we ever use, and it's on the second tab. Okay, number 1 looks approximately normal.
Yeah, number 3 looks possibly. I don't
Approximate.
know. No, I don't know. It looks real bad.
Oh, really? Did you sort smallest to largest?
Yeah. It goes like this.
Let's see what 3 looks like.
Let's make sure I cut the right data.
Sort. Smallest to largest. Nope, 3 looks good.
Yeah.
Looks like that last one that you did where in the middle it kind of goes up, but then it kind of goes down.
Yeah.
So-
It doesn't touch the line at all, except for 1 or 2.
Yeah, but it's still following within that
Okay.
flow. That's what you call approximately normal.
Okay, meat looks similar. Then this.
Did you do number 2? Yeah, they all kind of look about the same. They
Yeah.
follow that. And then it dips below and up.
Yeah. So I chose the first one, eh?
So let's see. The assumptions have been met. Safe to assume each group comes from a normally distributed population. I'll assume the assumptions have not been.
Hold on.
Yeah, I'd say the first one.
Or the second one, because the variations are equal. We can't.
Cannot assume that the variances are equal. Let me see what my variances are. Ooh, yeah, variable 2, the variances.
But we can't just assume from looking at QQ plots.
Yeah, cannot assume that the variances are equal. Yeah, I'd say the second one.
Oh, I just finally got my QQ plot to work. And it's I am having so much trouble copying and pasting right now. It's unbelievable.
We didn't have to use the sodiums.
Oh,
And I
man.
really didn't read
So
that.
the second
right.
one, right?
Calories for the first part. And number 15
Calories
is
as well.
running a test. The numbers got the same for all 3 types of hot dogs. Degree of freedoms are 2 and 51. 2 and 51, yeah.
Yeah.
F is 16.074.
Yep. 16.074, yep. And P is 0.
P is showing 3.86.
Yeah, but minus 6.
Oh, yeah. Sorry. Yep, I didn't see the E. Okay, so 0 with a level of significance. What conclusion can you draw?
So if the mean numbers are equal,
Different mean number of calories.
let me see again.
And at least 1 calories. Fourth.
This, so it'll be the same. We have
I didn't know I didn't look at it. Really with the H-box.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. I saw that in the homework. Oh, now we got to do the sodium. Do you guys disagree, or how do you feel about 15?
I'm trying to. So which one did you say for 15?
The fourth.
Sorry, which one?
The fourth one, we have sufficient evidence to claim that at least one of the hot dog types number of calories than another type. So you're basically rejecting the null hypothesis because we're at 0.
Yeah.
on the p-value.
Agree.
And we have sufficient evidence because it's goes on at 0.05.
Okay.
Y'all agree? Or do you understand why? The sodiums. Are you caught up with this, Brandon?
Yes, I'm caught up with you.
All right.
All right, so I think I did one of the QQ plots for the sodium levels. I did the.
Okay, so I'll do beef.
It's definitely not a straight line. Yeah, just give it a few more minutes.
They all three look close enough.
Loaded all three?
So yeah, just trying them close enough to me.
Alrighty, let's do the smallest to largest. Okay, put them in our.
The one that's furthest is probably the last one, I think.
I'm loading all mine in the ANOVA.
Okay. Okay, so what's the answer for 16?
Okay, looking at the means, looks like variable 3 is going to be the wildest. List. 0.78, 0.17. That's a big p-value. So let's look at 16. Looks like the smallest variance is, and the largest is that. Have the assumptions been met to use ANOVA?
Okay. So I have to close my quantitative procedures. I screwed up something.
Yes, the assumptions have been met because the largest is not greater than 2 times 7180. 360, 1.5. So that would be larger than the 10492. So assumptions have not been met. Have been
I'm
met.
still loading one again.
So
But something seriously wrong.
those are equal.
Let's see, the smallest variance on 7, yeah, and the largest one is that, yeah, got that. Have the assumptions.
See, that's where I think 14, there wasn't anything outside of that.
So it says here, you should see that the QQ plots for poultry suggest a possible problem with the normal assumption.
Over to R2D2.
Why is
I told her to do R2D2, but she didn't want to.
Oh. I don't know if I would want, Chase for pop rolls in the elephant from Alabama was, I think those are the winners.
Yeah, look how far it goes out.
Here, look at Ellie's outside. Anyway, what do you think of the muscle growth? Wow. No.
So, but on the QQ plots, they're all good, right?
Well, what it says to us in the question there, it says you should see that the QQ plot for poultry suggests a possible problem with the normal assumption. So it's telling us there's a problem with it. If you look at it, you can see there's a problem with it. It's not normally distributed.
With poultry, let me look at that one.
Hey, just why does it stop?
Copy.
I think it's 4, isn't it? The assumptions have not been met. It is not safe to assume each group comes from a normal distributed population, and we cannot assume that the variances are equal.
So I think the other one, well, we're gonna have to go back and change out previous one if that's the case. If this one's, let me look at it just a second.
No, this one's real bad. If you look at the middle section, it doesn't even flow. There's a massive gap between the middle section.
All right, guys. I'm so sorry. My kids are in the car waiting for me now. I got to get out of here.
Okay, cool.
I didn't.
Really?
I'm just going to leave it open and then try to figure out the last couple of problems when I get back.
Okay, cool.
Sorry, guys. I gotta run.
Cool.
All right, guys, let's go.
So if we take a each group comes from assumptions have not been met, it is not safe to assume each group comes from normally distributed population. So the very last one again.
Yeah, that's what I think it is.
And because of that one that was similar to this, where the middle were kind of stacked up in those three, you think that one was kind of like this one also?
I don't know if it was this bad, because look how far it goes out, and then look at pieces on line 6. Look how far that is.
Yeah,
a massive one.
All righty.
All right, bye.
What is the p-value for this test? So p-value is 0.179.
Yep. Do we have to put that in there? Is that what it asked? Yeah, you decide to use ANOVA to determine living levels. Yeah. So it's 0.179, eh?
Yep.
Okay.
How about the mean sodium levels? We have sufficient.
So P is greater.
Yes. So we do not have sufficient evidence to reject the claim. No, we have sufficient evidence. No, we can't. We do not have sufficient evidence to reject the claim. We fail to reject. All 3 hot dog types have the same mean sodium levels.
So it's the second one. Is that right?
Is that what you're thinking?
No, I only saw the 3. I didn't see the 4th one.
Sufficient evidence to claim that at least one of the hot dog Types has a different mean.
Need to go back and read quickly. Okay.
So we're rejecting the null, or we fail to reject the null. So we do not have sufficient evidence to reject the claim. I would say the second one.
Yeah. So we fail. So we failed to reject. That's the, I know that's the. So
Trying to figure out what that wording. We do not have sufficient evidence to reject the claim that all 3 hot dog types have the same mean sodium levels. All right, you want me to submit and see what we got?
Well, let me submit because I'm probably going to have to run,
Okay.
and then at least you've got 2 tries to get it right.
The only ones I'm concerned about are
Ow.
16.
Yeah, we got a few wrong. Okay, so 1's right, 2's right. Okay, so question 4, we got 0.33.
So, what requirements need to be checked when performing an ANOVA hypothesis?
Give
We
you
don't.
which ones are wrong because I've got to run as well.
I would get rid of the sample means are all positive.
Yeah, possibly.
Variance and maybe variances are equal in each group and data in each group are normally distributed.
Yeah, I'll have to read in that one. Then the next one is question 14 we got wrong.
I thought so. Let me see,
Okay.
12, 13, 14.
And question 16 we got wrong. That's it. Have you got those? Okay, cool. Okay, might as well stop the recording now then.
All right, you guys good?
Yeah, I'm going to run off to trick-or-treating quickly.
All right, enjoy.
Thanks, have a good one, man.